Let's take a look at how we can use Excel to plot stock price paths with random walks. We're going to assume that stock prices follow a geometric Brownian motion, which is given by the price in time period t equals the price the previous period times the exponential raised to the mu plus sigma zt. Mu represents the mean return, which is also known as the drift rate. Sigma stands for the standard deviation of returns. That's our measure of volatility. And ZT is a random variable that follows a standard normal distribution with zero mean and unit volatility. Okay, so the variables distributed normal, 0, 1. So let's start with some assumptions. We're going to use daily prices. We could easily do this with monthly or weekly as well. We're going to assume that the stock price begins at $100, that the mean return is 0.05%. Remember, these are daily returns. Return volatility is 1%. I'm going to assume there are about 250 trading days in a year. So to generate our random series in Excel, we can use the RAND and the norm inverse functions to generate ZT. So we'll put that in as norm.inv. You don't even need the dot. It'll work with the dot and it'll work without it. Open parenthesis, RAND, open parenthesis, and then just a closed parenthesis. You can put a value in here, but then it's going to generate the same random number. So by putting open and closed parenthesis, it's going to change that each time, and then you're going to get a different random variable, and hence you're going to get a different ZT. And you put in the mean of 0 and the standard deviation of 1. Then we're going to simulate the stock price with that formula. We know that the price today, or the price in time period t, is the price of the previous period, okay, times the exponential raised to the mu plus sigma zt power. And we'll do this for all the trading days. And we're going to assume that we're going to do it for 1,250 trading days. So that's approximately 5 years. But of course, you could do more or less years as you see fit. And then what we'll do is we'll plot the stock price path. We'll do it just for one replication. And we'll see in Excel that the path will change when we ask Excel to calculate now, which is the F9 key. Then we're going to plot the stock price path for several simulations or several replications. And this will allow us to see several paths at once. Okay, I'm only going to do 10 replications so the graph is readable, but you could do 100 or 1,000. It's just when you do more, there's just so much stuff on the graph that it gets kind of messy looking. So let's go to Excel. So I've tried to set this up so that we can get started here. The first thing we need is, we'd like to know what the trading days are. So I'm going to type in a 1 here, and I want this to go to 1,250. Now, I could sort of, put a formula in and copy it down, but an easy way to do that is on the Home tab. You see below the sigma, there's this, looks like a spreadsheet with a down arrow key. If you move over, it says fill. So you get that menu or that down arrow key. It's a series, columns. We want one-step increments, and we want to stop at 1,250. And if I hit enter, it fills it for me. So that's quite a bit easier than sort of dragging it down all those values. Now let's generate the ZT. We're going to use that norm inverse function. And we're going to say random, open parenthesis, close parenthesis, 0 for the mean, 1 for the standard deviation, and close that up. And we get a value. And I want to fill this all the way down. So again, I could drag this down, but if I move to that little box on the right-hand side, and I just double-click the left mouse key, it fills it for me. So that's the easiest way to fill it. There you go. All right, now let's do our calculation here. We want to put in this formula. It's going to be equals the previous period's price, right, times the exponential of the mean return here, mu. I'm going to put a $sign in front of that because I want that to stay the same. I want it to keep using the same mean return when I copy it down. Plus the volatility. And again, I'll put in a $sign there. And then times the value of ZT. And let me close that parenthesis. And we get a value. And again, I'm going to fill this by just moving over here and double-clicking the mouse. And I get a bunch of values. So let's see what this looks like if we plot this. So I'm going to go here, and then I'm going to go Control Shift down arrow key, and it highlights everything. I'm going to say Insert, and I want to insert a line graph, and you can see I get a graph. And you can see that it drifts upwards. And let's see if we, now I can't hit the F9 key here simply because the software I'm using doesn't allow me to do so. But if I go to formulas over here, this is the calculate now. And you can see how it changes. Right, every time I hit that button, you get a different path. So you can see it changes and it changes. So I've done this for 10 different paths here. And how did I do this? Let me make this a little bit bigger here. I have the same formula here. What I did is I copied the formula. So when you go, right click and you say copy, when you paste, right click, you can paste the whole thing, or I pasted this 1, 2, 3, which is just paste the number. So you notice if I hit this value, these things change, but the graph doesn't change. And so these are all just numbers from each replication. So I only did 10 replications, but you can see that even with 10, it's getting a little bit messy here. But you can see the different paths it takes, with the average path being in here somewhere, right? Maybe at, I don't know, 175. We could sort of try and figure that out. Let's see here. If we wanted to figure out the, what kind of return we might expect, we could say equals this 100 times 1 plus this mean return raised to the 1250 power. So let's see what we get. We get about $186.80. So if we go back to the graph here, you can see that there are values where there's some paths where it's over 250 and there's some paths where it's just barely 100, this path here. But, in the middle here is probably around 180 or something. So that looks pretty good. And again, if we could do more replications, we would get sort of a better average if we did that. But again, the graph gets very messy if you do a whole lot more than that. So I hope this was helpful. Okay, pretty easy to create the spreadsheet, pretty easy to see the graphs with this randomness and this drift factor. So you can see that, see what it looks like. So I hope this was helpful, and thanks for watching.